Good morning, everyone. Today's topic is from our third unit of ADC, okay? Oscillators. Before going to discuss about an oscillator, once I would like to revise our last class topics, okay? So in our last class, we would like to discuss about what? Class A push-pull power amplifier, Class B push-pull power amplifier. In Class A push-pull power amplifier, okay, the efficiency percentage will be less, and in Class B push-pull power amplifier, efficiency percentage will be more. And while coming to the major difference between the Class A power amplifier and Class B power amplifier is, in Class A power amplifier, the period of conduction is for 360 degrees. Means there the positive half cycles as well as the negative half cycles must be amplified. And while coming to the next one, Class B push-pull power amplifier. In Class B push-pull power amplifier, only either the positive half cycle or the negative half cycles must be amplified. Okay, but in Class A, both positive negative must be amplified. But here the conversion efficiency will be less. In Class B, it is more. And also single tuned amplifier and double tuned amplifier is over. In single tuned amplifier, it consisting of only one resonant circuit, and in double tuned circuit, it having two resonant circuits. So while coming to the single tuned amplifier, it amplifies only one frequency when the frequency of resonance circuit will matches the frequency of incoming signal. Only that signal will be amplified and all other will be rejected. But in double tuned amplifier, the frequency, two frequencies must be amplified. So these are the different kinds of Class A, Class B power amplifier, as well as single tuned and double tuned amplifiers also over. So here main advantage of tuned amplifiers are merely it is used to select particular frequency signals and reject all other frequencies. What is the main use of this one? It is used to select particular frequency and reject all other frequencies. Is it clear? And see here, while coming to today's topic, that is oscillator. Okay, so here the oscillator, the name itself indicates it is used to produce oscillations. Okay, what is the main function of oscillator? It is an electronic device which is used to produce oscillations. Oscillation means what? Vibration. Vibration means what? Waveform. For example, if I would like to take a stone and throw it, maybe it looking like this while it returns to the earth. Means the stone moved upwards initially, then it moved to the earth or returned to the earth due to the gravitational force. So how much force we are using depends upon that it makes one vibration. So simply oscillator is a circuit that is used to produce oscillations. Oscillations means vibrations or waveforms. So which kind of oscillations it is going to produce? It produces the oscillations having two signs, positive as well as negative phase. So finally, the oscillations produce 360 degrees phase shift only. Why? Because oscillator means vibration or waveform having both positive half cycle as well as negative half cycle. So to make positive half cycle, we have 180, and also to make negative half cycle, we required more 180. So total 360 degrees phase shift required to work one circuit as an oscillator. Why? Because to produce oscillations, 360 degrees phase shift is essential. Okay, so to start the oscillation with the constant amplitude, positive feedback is not the only sufficient condition. The oscillator circuit must satisfy the following two conditions. So here, while coming to the what are the conditions, already I said one condition, total phase shift around the circuit is how much? 360 degrees or 0. Why? Because if one circuit is able to produce circle only, that circle is able to produce waveforms. Why? Because cycle means it is made with positive half as well as negative half. Okay, so that satisfies one condition. If any circuit acts like an oscillator, it's going to produce 0 or 360 degrees. And to start the oscillation with constant amplitude, positive feedback not only sufficient. How the oscillator works, how the oscillator is made, already explained in feedback. Positive feedback is used in oscillator. What is meant by feedback? Connecting fraction of output back to the input is called feedback. What is meant by positive feedback? If the feedback signal is in phase with the input signal, then that is called what? Positive feedback. So see here, this is the amplifier circuit and it is the input signal. So this is the feedback network beta, and so it is what? Output signal. So Vf is equal to what? Beta into V naught, and here it is what? Vs source. So here V input is equal to Vs plus or minus A. But in oscillator it is equal to Vs plus Vf. If these are the signals, the input signal is like this, the feedback is also like this. If the input signal is like this, feedback also like this is Vin and this is Vf. Or otherwise, if the input signal is like this, the feedback signal also is like this. Means in this way, the signals are in phase. Which signals? Feedback signal and input signal. If feedback signal is in phase with the input signal, then the feedback is called positive feedback. So this positive feedback is used in circuits to produce the oscillations. And here one more important thing is, the oscillator not only requires positive feedback, it also requires two conditions. If one circuit having positive feedback without satisfying two conditions, not able to produce the oscillations. After satisfying that condition only, it able to produce the oscillations. In that way, the oscillator must and should satisfy two conditions. Already I said one condition, total phase shift around the circuit is equal to 0 or 360 degrees. And more one condition is there. So these two conditions together is called what? Barkhausen criteria. So these two principles together called what? Barkhausen criteria. So to start the oscillation with constant amplitude, positive feedback is not only sufficient, it also requires, or the circuit also able to satisfy two conditions. The two conditions together is called Barkhausen criteria. So what is the first condition? First condition is that the loop gain must be unity. How much it is? Unity. And this means the product of gain of amplifier A and the gain of feedback network beta has to be unity. Is it clear? The first condition is what? The magnitude of loop gain must be unity. Magnitude of loop gain must be unity. and the product of gain of amplifier A and the gain of feedback network is to be unity. And while coming to the second condition, the phase shift around the circuit must be is equal to 0 or 360 degrees. So see here, first condition is what? Loop gain must be is equal to unity, and total phase shift around the circuit is 0 or 360 degrees. These two conditions together is called what? Barkhasen criteria. So what is the topic? What are the conditions of an amplifier to work as an oscillator? So must ensure amplifier having positive feedback. Positive feedback means feedback signal is in phase with the input signal. And second condition is, in addition to the feedback, the circuit must and should satisfy the Barkhasen criteria. So here Barkhasen criteria means the product of loop gain, amplifier loop gain must be is equal to unity. That means the magnitude of loop gain is mathematically expressed as like this. So product of loop gain must be is equal to 1, we said now. So magnitude of product of loop gain must be is equal to 1, and total phase shift around the circuit is equal to 360 degrees or 0 degrees. These two conditions together are called Barkhasen criteria. These two conditions are called Barkhasen criteria. Okay. And see here, in addition to the principles Barkhasen criteria, the circuit must and should having some elements in addition to the feedback circuit. So these are called what? Requisites of an amplifier to work as an oscillator. So those are the conditions, these are the requirement. Is it clear? Condition is different from the requisites. Okay. So while coming to the requisites or requirements of an oscillator, it must and should require tank circuit to produce the oscillation, and also it requires amplifier circuits, and also it requires feedback circuits. What are the requisites of an oscillator? It requires tank circuit, it requires amplifier circuit, it requires feedback circuit. While coming to the first one, what is the first one? Tank circuit. So see here, this is the diagram of tank circuit. Once observe it carefully. So where we find this? In tuned amplifiers we find this. If an inductor is connected in parallel with the capacitor, then the name of the circuit is called tank circuit. Then the name of the circuit is called what? Tank circuit. How it is formed? The tank circuit consists of inductor is in parallel with the capacitor. If the inductor is connected in parallel with the capacitor, then the circuit is called what? Tank circuit. And here frequency of the tank circuit is given by 1 by 2 pi under root LC. So here L is the value of inductance, C is the value of capacitor. So by placing the inductor and capacitor values, theoretically we find the frequency of oscillations produced by the oscillator. Is it clear? Even though without calculating the frequency of getting oscillations, mathematically, theoretically we can prove or we can find the frequency of oscillations by putting the values of inductor and capacitor in the given formula. F is equal to 1 by 2 pi under root LC. And see here the frequency of oscillations will depends upon capacitor and inductor values now. So at what condition it will produce? When the frequency of the tank circuit is equal to the frequency of incoming signal, only at that moment the circuit going to start oscillations. Because of here the frequency must be depends upon the inductor and capacitor. The name of this circuit is called frequency determining circuits. What is the name of this circuit? Tank circuit, frequency determining circuits. Okay. What is the name of the frequency determining circuit? Tank circuit is also called frequency determining network. And the values of L and C determines the frequency of oscillations produced by the tank circuit, and is given by F is equal to 1 by 2 pi under root LC. Already I said that L is the inductor of the coil and C is the capacitance of the capacitor. So in RC oscillators, inductor is replaced by resistor, but whatever it may be, it requires one tank circuit to produce the oscillations. Okay, and see here, and the next one is what? Transistor amplifier. So this diagram will show the amplifier circuit. Already we seen here. So the tank circuit is connected here, and this is the feedback network, and that is the amplifier. The oscillator of the tank circuits are fed to the transistor amplifier. It amplifies the oscillations produced by the tank circuits. So last one is what? Feedback circuit. Already I explained you about feedback in previous classes. So what is meant by feedback? Connecting fraction of output back to the input is called feedback. What is meant by feedback? Connecting fraction of output back to the input is called feedback. So in oscillators, positive feedback is used. What is meant by positive feedback? If the feedback signal is in phase with the input signal, then the feedback is called positive feedback. So here the function of feedback circuit is to supply a part of output energy to the tank circuit in the correct phase, and the amount of energy feedback to tank circuit sufficient to meet R by 2 losses in the tank circuit. And see here, while coming to the next topic, statement of Barkhausen criteria in oscillators. Already I said you know what is meant by Barkhausen criteria. So here Barkhausen criteria means what? The product of loop gain must be is equal to 1, and the total phase shift around the circuit is equal to 0 or 360 degrees. And see here, while coming to the derivation of Barkhausen criteria, initially for any feedback circuits, already explained like this. Once see the diagram. Okay, see here. So here V input voltage is what? Vs plus Vf. So here V input voltage is what? Vs plus Vf. And here Vf is equal to what? Beta feedback factor into V naught. Okay. Vi is equal to Vs plus Vf. And by substituting feedback voltage, Vf is equal to beta into V naught. So here beta is equal to what? Vf by V naught. And by substituting this value here, so Vf plus beta into V naught into A is equal to Vb into V naught, VB into V naught, and AVS plus AB V naught is equal to V naught. After substituting the values here, we are getting AVS is equal to V naught into 1 minus A beta. So therefore V naught by Vs is equal to A by 1 minus A beta. And here AF is equal to output voltage by input voltage, that is V naught by Vs. So the gain with feedback, positive feedback, is getting from the equation AF is equal to 1 by A beta. So where AB is the feedback factor or loop gain, if AB is equal to 1, then AF is equal to infinity. The gain becomes infinity. Okay, where A beta is the feedback factor or loop gain. If A beta is 1, then AF is equal to infinity. Thus the gain becomes infinity. That there, if output without any input, therefore amplify this condition works as an oscillator. So what is the condition? A beta is equal to 1. So it is called what? Barkhausen criteria. And see here. While coming to the next topic, already oscillator is over, what are the requisites is over, and also what are the conditions of oscillator is also over. So next one is what? Classification of oscillators. So according to the factors, oscillators may classified into many types. So first thing here it is according to the waveform generated. According to the waveform generated or according to the components used. Here the oscillators are classified into 4 types. LC oscillator, tuned oscillator, Hartley oscillator, as well as Colpitts oscillator. So according to the waveform generation, how many types of oscillators are there here? 4 types are there. What are the 4 types? LC oscillators, tuned collector oscillators, Hartley oscillators, as well as Colpitts oscillators. Okay, and while coming to the next next one is RC phase shift oscillator, means sinusoidal oscillators are again classified into 3 types: LC oscillator, tuned collector oscillator, Hartley oscillator, Colpitts oscillator, as well as RC oscillators. Okay, here sinusoidal are of 2 types, one is of LC, other is of RC. In LC, Colpitts Hartley tuned oscillators are there, but in RC oscillator, the RC phase shift oscillator is there, Wien-Bridge oscillator is there, crystal oscillator is there. So see here, in LC oscillators, according to the type of circuit used or according to the waveform produced, first one is LC oscillators. In LC oscillator, the tank circuit is made with inductor and capacitor. If it is made with single inductor and single capacitor, then the name of the circuit is called tuned collector oscillator. What it is name? Tuned What is the name of this? Tuned circuit oscillator. If the circuit containing only one inductor and one capacitor, then that is called single tuned amplifier or oscillator. And if the circuit having two inductors and one capacitor, looking like this, Then the circuit is called Hartley oscillator. If tank circuit having two inductors and one capacitor, then the name of the circuit is called Hartley oscillator. And the next one is Colpitts oscillator. So what is meant by Colpitts oscillator means in the tank circuit it consisting of two capacitors and one inductor, then the circuit is called Colpitts. Finally, here the tank circuit containing only the inductors and capacitors. If it having only one inductor and one capacitor, that is called tuned collector oscillator. If it having two inductors and one capacitor, then it is called Hartley oscillator. Or if it having two inductors and one capacitor, then that is called Colpitts oscillator. And next one is RC oscillator. The RC phase shift oscillator, Wien-Bridge oscillator, crystal oscillator. So RC phase shift oscillator, in RC oscillators, the tank circuit is made with RC elements, resistor and capacitors. Okay, so by using resistor and capacitor, three kinds of oscillators are there: RC oscillator, Wien-Bridge oscillator, crystal. And while coming to the non-sinusoidal oscillator, these are the oscillators are able to produce non-sinusoidal waveforms. Non-sinusoidal waveforms. And while coming to the non-sinusoidal oscillators, multivibrators are there, sweep circuits are there, blocking oscillators are there. Okay, what are the main circuits here? Non-sinusoidal oscillator, multivibrators, sweep circuits, blocking oscillators. And next one, according to the frequency range means the amplifier amplify the signals having this range only. If it is an audio frequency oscillator, the oscillator will produce the oscillations having the frequency in the range of 20 to 20 kHz. Is it okay? Audio frequency oscillator means it is an oscillator which is used to produce the oscillations of having frequency 20 Hz to 20 kHz. And while coming to the radio frequency oscillators, these are the oscillators are able to produce the oscillations in the range of having about 20 kHz to 30 megahertz. And while coming to the next one, video frequency oscillators. These are the oscillators are used to produce the oscillations from 5 megahertz. Very less frequency. Okay. And while coming to the next one, high frequency oscillator. It amplifies the signals or it produces the oscillations having the frequency how much? 1.5 megahertz. Very lengthy. And very high frequency oscillators also there. That is 30 megahertz to 300 megahertz. That means what? If the oscillators are able to produce the oscillations in the range of 30 megahertz to 300 megahertz, then the name of the oscillator is called very high frequency oscillator. And according to the component used, which components are used? Already I said in the tank circuit made with inductor and capacitor, then that is called LC oscillator. The tank circuit is made with resistor and capacitor. Now the circuit is called RC oscillator. And if the circuit is made with quartz crystal, then the name of the circuit is called crystal oscillators. Is it clear? These are the variety of classification of our oscillators. Okay, how many types of oscillators we are watching here? According to the waveform generated, sinusoidal is there, non-sinusoidal is there. In sinusoidal, they are classified into LC oscillator, RC oscillator. And next one is in LC, tuned is there, Colpitts is there, Hartley is there. And in next one, LC, Hartley, Colpitts is over, RC oscillators. In RC oscillators, RC oscillator is there, Wien-Bridge oscillator is also there. But while coming to the frequency range, according to their frequency range, are again classified into audio frequency oscillator from 20 to 20 kHz and a radio frequency oscillator from 20 kHz to 30 MHz. And here the video frequency of an RF oscillator produce the frequency within range of 5 MHz. And high frequency oscillators also there. They would able to provide 1.5 MHz to 30 MHz. And very high frequency oscillators will produce the signals having the frequency more than that of 30 MHz to 300 MHz. And last one is what? According to the components, these are again classified into LC oscillator, RC oscillator as well as crystal oscillator. And see here, next topic is very important topic is Hartley oscillator. So first I would like to draw the diagram roughly. See here. See here, simply it looks like a RC coupled amplifier, but in place of here it consisting of in Hartley 2 inductors as well as 1 capacitors, 2 inductor and 1 capacitor. That means what? Here the tank circuit having inductors and capacitor. Okay, and see here in the circuit diagram, resistors R1 and R2 give a potential delivered has to the transistor. Is it clear? The emitter resistor whose job is to provide the thermal stability. And the circuit diagram, it also consisting of resistors R1 and R2. Already I said number of times, more number of times. It provides potential divider biasing of transistors. And C is the emitter bypass capacitor which bypasses the signals to the ground. And if the emitter bypass capacitor not there, the amplified AC voltage will drop across RA and it will get added base emitter voltage, and W1 will disturb the biasing condition. So if Cin is the input decoupling capacitor, while code is output DC decoupling capacitor only. And see here, the task of DC coupling capacitor is prevent DC voltage from reaching succeeding stages. Is it clear? And here in the circuit, see here, this is the circuit diagram. This is the circuit diagram of Hartley oscillator. Already I said Hartley oscillator means it is the combination of these two, and Akka is calling to 180 degrees. So here 180 degrees phase shift to the tank circuit. Both L1 and L2 are connected in parallel. Both L1 and L2 are connected in parallel, and it is connected in L1, L2. Connected internally in series, finally these two are connected in parallel to the capacitor. These two are connected in parallel to the capacitor. Okay, how the tank circuit is made? It is made with two inductors connected in parallel and one capacitor. But inductors are internally connected in series, and the series combination of two inductors L1 and L2 are connected to the capacitor to form the tank circuit. And here two resistors are used for the purpose of biasing. So it is what? Potential divider biasing network. The R1, R2 is used for providing biasing and stabilization. So here these two provides emitter base junction is in forward bias condition and collector base junction is in reverse bias condition. Finally, the transistor makes operate in active region. Transistor operates in active region. And the output, that means sample of output, is connected to the base of transistor through the coupling capacitor Cc2. So here what is the need of coupling capacitor? Why we are using this? If the coupling capacitor is absent, what happens? So why it is means it will connect the output voltage back to the input, and same way it will allow only the AC and it will block the DC. So that's why here the coupling capacitors are used. And next one is RE and CE. So here RE and CE are called bypassing elements. This provides low reactance path to the oscillations. And across the collector terminal of transistor, one coil is also used. When this coil frequency is matches with the input signal frequency, then only the circuit works as an oscillator. Okay, and here for that purpose we are using RFC, radio frequency coil, across the collector of Q. And here more one element is also there, CC1. So CC1 indicate what? Coupling capacitor. It is used to connect the output of one stage to the input of next stage. And this output is connected to the transistor through the tank circuit. Already I said here the tank circuit is made with two inductors and one capacitor. What are the two inductors? L1 and L2. So these are connected in series and parallelly connected to the So here the capacitors are used to connect the output of one stage to the input of next stage. So this is the construction of Hartley oscillator. So what are the main components here we are using? Two inductors, one capacitor. Potential divider network R1, R2 is also there. Coupling capacitor CC2 is also there. Okay. So while coming to the operation, if the input voltage is connected across the base of the transistor will provide 180 degrees phase shift, and the remaining 180 degrees phase shift will be provided by the tank circuit. Cause of charging and discharging of inductors 1 and 2 and capacitor, the total phase shift around the circuit is 180, and the transistor is able to produce 180 degrees. So total phase shift around the circuit is how much? 360. Now the circuit starts oscillation. Means now it is able to produce oscillation. So already I explained, but once I would like to read the slide. See here. When the power supply is switched on, the transistor starts conducting and the collector current increased. As a result of capacitor C1 starts charging, And when the capacitor C1 is fully charged, it's discharging through the coil L1. This charging and discharging of inductors and capacitors will create 180 degrees phase shift. And the oscillations produced in the tank circuit is fed to the base of Q1, that is transistor, and it appears in the amplified form across the collector. And in output voltage of transistor will be in phase with the voltage across inductor. That means here the feedback voltage must be in phase with the input voltage. So in this way, total phase shift around the circuit is how much? 360 degrees. And now the circuit starts oscillating, means now it is able to produce oscillations. And the frequency of the given oscillations is given by 1/2 root LC. And next one, see here, this is the expression for Hartley oscillator. So frequency of the Hartley oscillator is given by 1/2 under root LC only, but here in place of LC, L indicates total inductance, but here we are having two inductors now, so LT is equal to L1 plus L2, and the attenuation beta is equal to L1 by L2. Okay, and capacitor value we can write directly. Why? Because we are only having one capacitor. And if these two coils are connected in series, means two inductors coils are connected in series, then total inductance will be L1 plus L2. If these two coils are connected in series opposition, the total inductance is L1 plus L2 minus 2M. Okay. And our next topic is Colpitts oscillator. So Colpitts oscillator is similar, construction is very similar that of Hartley oscillator, except the inductors are replaced with capacitors. Except capacitors, inductors are replaced with capacitor. Simply the tank circuit. Except tank circuit, construction is same. It consisting of input capacitor that is used to connect the feedback voltage back to the base of transistor, and R1 are to provide proper biasing and stabilization. Here RFC is used for the purpose of connecting output to next one, and C output means output capacitor is used to provide proper signal to the load, and the output voltage given to the tank circuit. But now here the tank circuit is made with two capacitors and one inductor. In Hartley oscillators, two inductors and one capacitor, but here two capacitor and one inductor is there. If the circuit having two capacitors and one inductor in the tank circuit, then the name of the circuit is called Colpitts oscillator. Then the name of the circuit is called what? Colpitts oscillator. Let me explain. Once check the slide. So the oscillator is almost a Hartley oscillator already, except the tank circuit. And while coming to the operation, it is made with high frequency sinusoidal oscillations with radio frequency. And the capacitors C1 and C2 forms tapped capacitance in the tank circuit can be used as source for the feedback. The capacitor CE is connected. Emitter bypass capacitor provide low reactance path to the signal. And already I said R1 and R2 provides potential divider biasing. And see, while coming to the working, whatever I explained initially, the input is applied across the base of the transistor, is amplified and provides 180 degrees phase shift. And the amplified signal is given to the tank circuit. Cause of capacitor charging and discharging and inductor charging and discharging, again the signal attains 180 degrees phase shift. So total 360 degrees is achieved. The circuit will able to produce the oscillations. So this is the working of what? Colpitts oscillator. Okay, whatever I explained, this is only there in here in the slide. once you check the slides and see here these are the conditions for sustained oscillations of Colpitt's oscillators. So what are the conditions? The total phase shift must be 360 degrees or 0, and two capacitors are center tapped and grounded. The voltage across capacitor C2 is 180 degrees with the voltage across capacitor C1. Okay, so these are the different conditions, and the frequency is given by 1 by 2 pi under root LC. But here L is only 1, that means only we are having one inductor, but two capacitors are there. The capacitors are connected in series fashion. So the total capacitance in the circuit is C1 C2 by C1 plus C2. So the frequency is equal to 2 pi under root of L into C. So C indicates total capacitance of the capacitor. Okay. So this is about today's class. Today we are discussed about Hartley and Colpitt's oscillator. Now I would like to end the session.